All right, let's solve a couple more systems of equations. On that last problem, I said that we want to choose a variable that has either a 1 or a -1 for its coefficient. You can see both of these y's. This y has a 1 for a coefficient. This y has a -1 for a coefficient. The reason we want to solve for those sorts of variables is because if I could technically solve for maybe this x, but in doing so, if I was to solve this equation for x, well, let's just look to see what would happen. I would get -4x plus y. It's supposed to be a -4x plus y equals 1. If I'm solving for this x, that means I'd want to start by subtracting y from both sides. I get -4x equals the opposite of y plus 1, and then divide both sides by -4. It's this dividing both sides by -4 that, while it's not a problem, it makes things more difficult, because you can see we introduce fractions. We have x equals 1/4 y minus 1/4. And at this point, I could technically plug this in back for the value of x in the other equation. But I'd rather not work with fractions if possible. So I'm going to scrap this and start this over and say, okay, well, I'm going to actually solve the first equation for y. I'm solving the first equation for y, again, because its coefficient is 1. So it's actually only going to take me one step to solve this equation for y. If I have -4x plus y equals 1, when I add 4x to both sides, I get y equals 4x plus 1. It's a single step to solve that equation for y. And then that means I can plug that thing into the second equation. You can see when I'm solving the first equation for y, then I plug that thing, the other side of the equation, into the other equation. So let's see, 8x minus y equals 5. This is saying y is equal to this, so that gets plugged in for y. So I get 8x minus parentheses 4x plus 4 equals 5. It was necessary that I put these parentheses here, because I'm saying I need to subtract the contents of y, or subtract the entirety of y, and y is 4x plus 1. So in other words, I want to make sure that I have that addition of 4x, the 4x and 1 done before I do the subtraction. Now that I've written it with parentheses, now I can solve this by simplifying. So I'm going to distribute my -1 through the parentheses, giving me 8x minus 4x minus 1 equals 5. Combine like terms, I get 4x minus 1 equals 5. Add 1 to both sides, I get 4x equals 6. And x equals, well, when I divide both sides by 4, x equals 3/2. So it's not always possible that we can avoid fractions in their entirety. If the solution happens to be fractional value, well, there's not much I can do about that. But at least I didn't have to work with fractions throughout this whole process. All right, so now I know the x-coordinate of my solution. I'm going to plug it back into either of these equations. Actually, I'm going to choose the one I solved for y already, because it's easier. Plug back into 1. So I get y equals 4x plus 1. I'm plugging x equals 3/2 in here. So y equals 4 times 3/2 plus 1. When I cancel a factor of 2, I get 2 times 3. So I get y equals 6 plus 1, or y equals 7. So in total, I have the point 3/2, comma, 7. And, it's all well and good to check these things by hand, but we have calculators. So I'm going to start being a little bit more lazy, and I'm going to check this on the calculator. So to check it on the calculator, I'm going to do -4, because this is -4x plus y equals 1. So -4 times, well, for my x, it's 3/2. So I'm going to put that in parentheses just to make sure that the order of operations works out. Plus y, that's 7. And instead of saying equals 1, I'm just going to press enter to see what the left-hand side of this equation evaluates out to. The left-hand side is 1, the right-hand side is 1, so I can actually verify that, yes, this equation, at this point, does satisfy the first equation. Now let's check it with the second equation. 8 times actually I don't need the times in there, so 3/2 minus 7 I expect this to be a 5, and there you go, it's a 5. So I've actually verified that this point is the solution to that system of equations. I think that the checking step is always worth doing, personally, especially when you're learning this material, when you're trying to figure out what's going on. But even at my stage, where I've been doing this for a little while, I do feel it's necessary to check my work. Let's kind of step back through the steps of what I did here, though. So first off, when we're solving a system of equations using the substitution method, I start off by picking a variable that I want to solve for. And that variable is either going to have a coefficient of 1 or -1. When I pick that variable, I solve the appropriate equation. In my examples, I was always solving the first equation for y, but it doesn't have to be that way. We don't always have to solve for y. If we want to solve for y, well, that means isolating that y there. We plug that value, so this ends up saying y equals something. We'll plug that value in for the y into the other equation and solve that resulting equation. That tells us one of the two coordinates of our solution. Now, once we have one of the two coordinates, we can plug that value into either of the equations, and it tells us the other coordinate. Therefore, we have both points, or both coordinates to our point.